Welcome to the IEEE NAV SDN 2025 in Athens. Thanks for coming and presenting your demo. Please, could you give us a brief overview of your demo?
Okay, thank you for inviting us to show our work here. I'm going to show a demo, but first of all, I will introduce our case. Most of people tend to think that astronomers work this way. So we go to our office and we look at fancy pictures, beautiful pictures, but this is not the case. We are more used to this kind of thing. So we try to install applications. They never run at the first time. So we end up wasting a lot of time trying to install these kind of applications. Another issue we have is that lately, the last instrument we have built in astronomy, they are creating huge sets of data sets. So we are creating like petabytes of data every year, and we have problems now to handle this kind of data. And the other issue is the compatibility of the software tools we use for the analysis of this kind of data. We deal with old software, which actually works, but it's impossible to install in modern machines. The programs are complex and they are hard to handle. So we joined the AC3 project, which is a European project that combines the cloud and edge computing with artificial intelligence to make all the processes faster, simpler, and more efficient in the end. And we are one of the use cases, the third one. So the way we are approaching these problems are using containers and Kubernetes. We containerize our software tools like PPXF, Starlight, and StackMap. And like this, we are sure that they work in the same way every time we run it in any machine. And we combine it with Kubernetes, which will make the analysis parallel. So this is how we handle the problem with the amount of data we need to process. And here, just to show you the example of the kind of data we use, they are called data cubes because they have 3 dimensions. So we'll have 2 dimensions for the spatial information of galaxies and a third one for the spectral information, which is the information we need to do our analysis of the data. Here you can see real data, real astronomical data. And this is how we analyze them. We use full spectral fitting tools like the ones I said earlier. So we combine information for models to compare with our real observations in order to get all the information we need from them. And we will end up with this kind of maps, which are real maps. This is real science already published. So this is the goal of the project, maybe. And this is the general strategy we're following. We start with a three-dimensional data cube. We split the data cube into the individual spectrum. We package them in a Docker file, in a Docker container, and we run all the analysis. And then when we get the analysis done, we can reconstruct the original data cube with the spatial information we got in the beginning. So that's the goal of the whole project. And for that, we have built this application where we have the general pipeline with all the tools here we want to use. So for instance, this tool is PPXF. So the only thing you need to do is to create your own data set with your favorite galaxy. I'm gonna choose this one with this fancy name. You set your parameters to the analysis. You create the data set. It will show up here, eventually here. Then you can drop a couple of files there. You can upload it. They will show up here. Here you go. And then the only thing you need to do your analysis is pressing the play button, and it will appear here in the progress bar. And well, this will take a couple of minutes, but in the meantime, I can show you results from other galaxies we have analyzed. Here are the input files, and here will show up the output files we get from the analysis. We can download it, the whole folder or individual files, and also we have this cool tool where you can go to your galaxy. Here, this is the galaxy we have analyzed, this one. So here you can click and you will have all your fittings here of all the pixels in this galaxy. And also you can click here and you will have your maps overplotting on top of your galaxy. And that's it. That's the goal of the project. And now we have it working right now. And yeah, that's
Thank
it.
you. So, why someone from your society, from astronomical society, should use the AC3 solution? Which is
Well,
the major benefit for your society?
the major benefit is that you don't need to use your computer anymore. I mean, this is going to be done in the cloud. So you don't need a very powerful computer. So you will save in this case. And also you don't need to deal with the installation of the software. You don't need to deal with the time you need to analyze all the spectra, because you have here all the tools necessary to parallelize all the analysis. So this is a huge advantage for astronomy.
Okay, thank you very much.
Thank you,
Thank you.
Christos.
Thank you,
Thank you.
Mario.